Good afternoon, everyone. In this video, we will be discussing entity relationship modeling. A data model is an integrated collection of concepts that represents real-world objects, events, and their relationships. There are two types of data models: object-based data models and relation-based data models. In database design, we develop an object-based model first. Examples are entity relationship model, functional model, and object-oriented model, then systematically convert those models into a relation-based model. This is more suitable for database implementation. An entity relationship model describes data in terms of the following: entities, relationship between entities, and attributes of entities. We graphically display an ER model using an entity relationship diagram or ER diagram. This illustration is an example of an ER diagram. When we say entity, it is an object that exists and which is distinguishable from other objects. It can be a person, a place, an object, an event, or a concept. Examples are: for the person, we can have student, employee, or client. For object, we can have couch, airplane, machine. For place, we can have city, park, room, warehouse, event, war, marriage, lease, concept, project, account, course. The entity representation in an ER diagram is shown in this illustration. The entity is enclosed in the shape of a rectangle. An entity type defines a collection of entities that have the same attributes. An entity instance is a single item in this collection. An entity set is a set of entity instances. For example, the entity type is student. An instance is the student with ID number 555555555. One particular student is an example of an entity instance. The entity set is the collection of all students. Attributes. An attribute is a property or characteristic of an entity type. We represent an entity with a set of attributes. Examples: for the student entity, the attributes are student ID, SSN, name, address, phone, email, or date of birth. For example, entity order, the attributes are order ID, date of order, amount of order. For the account entity, we have attributes, account number, account type, balance. For the city entity, we have name, state, population. For the attribute types, we have simple, composite, single-valued, multi-valued, stored, and derived. This is an example illustration of an ER diagram which shows the attributes of the entity student. The attributes in the ER diagram are inside the oval or a double oval or a dashed line oval. Next, we have the type simple and composite attributes. A simple or an atomic attribute cannot be further divided into smaller components. Examples are city and state. While a composite attribute, however, can be divided into smaller subparts, where each subpart represents an independent attribute. Examples: the name attribute can be divided into first name, or last name. The address attribute is a composite attribute because it can be divided into street, city, state, or zip. We also have the types of attributes called single-valued and multi-valued. Single-valued attributes have a single value for an entity instance. Examples: the major, the date of birth. For example, a student can have only one major course, or the student only has one date of birth. Multi-valued attributes, on the other hand, may have more than one value for an entity instance. These are denoted with a double-lined ellipse. The double-lined oval in our illustration in the previous slide is an example of a multi-valued attributes. Example attributes that are multi-valued are languages. That means, for example, a student entity, one particular student can have many languages, or a student can speak many languages. Stored and derived attributes. The value of a derived attribute can be determined by analyzing other attributes. Therefore, no need to store them in the database, denoted with a dashed ellipse. Example, the age. The age of a student, for example, can be calculated from its date of birth. An attribute whose value cannot be derived from the values of other attributes is called a stored attribute. A key attribute or identifier is a single attribute or a combination of attributes that uniquely identify an individual instance of an entity type. These attributes are underlined in an ER diagram. Example is the student ID attribute of the student entity. This means that there is only one student ID per student. The candidate key attribute. Sometimes no single attribute can uniquely identify an instance of an entity type. A composite key is a composite attribute that uniquely identifies each entity instance. Example, the city entity has the name and the state as their key attributes. So there are multiple key attributes, so this is what we call a composite key. Next, relationships. A relationship is an association among several entities. Examples are student takes courses. Here, the entities are the student and the courses. And the relationship of the student and the courses is the relationship takes. Next, we have another example. Customer has account. The customer and account entities has the relationship called has. This relationship is represented by diamond-shaped box that connects the two relating entities. This illustration shows the relationship between customer and account entities. The relationship has is enclosed in the diamond-shaped box. Degree of a relationship. The number of entity sets that participate in a relationship is called the degree of relationship. Three common degrees in a database are unary with degree 1, binary with degree 2, and ternary with degree 3. A unary is an association between two instances of the same entity type. That is, R is a relation whose elements are E1 and E1. While binary is an association between two instances of two different types. That means there are two different entities and there are connections or relationship between two instances of those two entities. A ternary is an association between three instances of three different types. That means there are three instances that has relationship, and those three instances are coming from three different entity types. Here we have what we call the cardinality of a relationship. A maximum cardinality represents the maximum number of instances of entity B that can be associated with any instance of entity A. The four types of relationships between entity types are one-to-one, one-to-many, many-to-one, and many-to-many. Notice that in one-to-one, only one instance of entity A is in relationship with only one instance in entity B. In one-to-many, one instance in entity A has a relation or association with many instances of another entity, which is the entity B. In many-to-one, many instances of entity A has an association to one instance of entity B. In many-to-many, there are many instances that have association to many instances of entity B. Maximum cardinality. The relationship types by maximum cardinality are one-to-one, one-to-many, and vice versa, or that is also many-to-one and many-to-many. So these are our illustration in the ER diagram. If there is a one-to-one, we just put a 1 beside the entity. And if it's many, we put the crow foot sign beside the entity. We also have the minimum cardinality. The minimum cardinality of a relationship is defined as the minimum number of instances of entity B that must be associated with each instance of entity A. The two types of minimum cardinality are optional and mandatory. For optional, we put 0 beside the entity, while mandatory, we put 1 beside the entity. For unary relationships, we have these examples. For one-to-one unary, here we have a person. We only have one entity that is married to the same entity type. We have only one entity here, which is the person, and this is an example of a unary, one entity only. So that this means that one instance or one person is married to another person. And then we put here an attribute to the relationship is married to. That pertains to the data about the relationship is married to. Next example, one-to-one unary relationship. Unary relationship because we only have one entity, and that is employee. Employee supervises employee. This means that one employee supervises another employee. And then we can see there that the maximum cardinality is 1 to 1. And the minimum cardinality is optional. The third example, we have part uses part. Here we have a many-to-many relationship. Many is denoted by the crow's foot symbol, and the minimum cardinality is optional, denoted by the 0. So this means that many parts can be used by many parts, or many parts uses many parts. And the optional there means that a part may not be used by another part because it's optional, and a part may use no part. Next, we have a binary relationships. Shown here, we have two entities in one relationship. That is a binary relationship. First example is a one-to-one relationship with two entities, employee and department. Employee, the relationship is manages the department. So there is a one-to-one relationship, means that only one employee manages only one department. And the optional part of the department means that one employee may not be a manager, or a one employee manages at least 0 department, or there is at least one employee that does not manage a department. Next, we have a one-to-many relationship with customer, entity, and order. Its relationship is places, which means that the customer places order. The relationship of the two entities is places. And this is one-to-many because a customer can place many orders. Again, one customer can place many orders. Take note that the order is many, but the customer is only one, because one order can be placed by many customers, or one order can be ordered by many customers. And here the order is optional because a customer may not place a specific order. And the customer is mandatory because an order must be placed by at least one customer. Next example is the student and the course. Relationship is registers, and here the student and the course relationship is many-to-many. The course here pertains to the subject. So a student can enroll or register to many subjects, and one subject or course is registered by many students, or one subject has many students. And the minimum cardinality is 1-to-1. It is not allowed that the student don't have a subject, and vice versa. A course should have at least one student. That is why both of them is mandatory. Next, we have a ternary relationship. There are 3 entities. In the first example, we have musician, composition, and venue. The relationship of the 3 entities are performs. Here, you don't need to specify the maximum and the minimum cardinality if it is ternary relationship. Next, here, the relationship performs has an attribute rating. Another example is the student, equipment, and project. They have the relationship uses, and there's the data that needs to be recorded that pertains to the uses relationship, and that is the date. So we use the date as an attribute of the relationship uses. This assumes that you cannot see the attributes of the student, equipment, and project here, but we're just focusing here on the relationships of the three entities. But in your modeling, you should specify the attributes of the entities student, project, and equipment. The attributes of relationships. An attribute on a relationship stores information related to the relationship. It is much like attributes on entity types. Here in the illustration, we have the example quantity attribute, that is the attribute of the relationship. Contains. Associative entities. An associative entity is an entity type that connects the instances of one or more entity types and contains attributes particular to this association. Allows us to store data from relationship attributes more effectively. The relationship meets one of the following conditions. It is a many-to-many binary relationship, and it is a ternary relationship, or a relationship of an even higher degree. So that means we can make an associative entities based on these conditions. Examples. We see here the entities student and activity. Because their relationship is many-to-many, the participates becomes an associative entity. The relationship becomes an entity, as shown in the second example. Here, the participates become enrollment. The student enrollment activity. And the relationship there is many-to-many. Another example, this is a ternary relationship. If the ternary, or if the relationship is ternary, or there are three entities in one relationship, the relationship becomes an associative entity. It becomes an entity. The performs now becomes performance in the second figure. We also have what we call the weak entity types. A strong entity type exists independent of the other entity types, while a weak entity type depends on another entity type. Entity type depends on the identifying owner. So for example, we have the student entity, and it has dependent. Dependent is an example of a weak entity, because if it depends on the student entity, its existence depends on the existence of the student entity. While the student is independent, so it is a strong entity. Even without the dependent entity, the student entity will exist. Now, the weak entity is illustrated with a double-lined rectangle, and its relationship also has a double-line diamond-shaped box.